So let's go. So hi, everybody. My name is Idit Levine. I'm the founder and CEO of Solo.io. And this is Yuval. He's the chief architect of the company. And we want to talk to you a little bit about debugging in Envoy. So let's start. So first of all, let's understand the problem just to make sure that we are baselining it, right? So what is the problem? So the problem in debugging microservices is the fact that everything is distributed, right? Back on the day, it was really, really simple to take one monolithic application, attach a debugger, and see the state of the application. But that's not the case right now, right? Because now we have a lot of little microservices, and you kind of like lost the big state of the application. An application, here we have like 7 microservices. Usually it's much more, right? It looks something like that, right? And then you see a lot of people tweeting something like that, right? Because this is a real problem, right? So a good question is how to fix it. And when we look at it, we decided to create Squash. So let me show you a quick demo about how it's actually working, and then we will understand how it's tied to Envoy. OK, so spinning it in AWS, it will take a sec. And then we will show you. Yeah, don't worry about that. That's not the demo. That's like script that I'm running that's setting up the environment. But I will make that bigger if you cannot see that. So take a sec. And we have time to spare because we have a full 10 minutes. So. OK. So the pod is almost up, and then we will show you it. Soon. Just giving it the timer to make sure that it's running. OK, here you go. It's coming. OK, so this is a very, very simple application that we build. It's really, really simple, and I hope everybody can see that. This is the grade and subtract application. So it's really simple. Basically, it's a very complex calculator that's getting 2 parameters, and I will show you, give no matter which number, and basically calculate the number. As you can see, it's not working, right? But what are people doing in that case, right? Because this is happening all the time. And what people actually is doing, they troubleshoot. Because debugging is not an option for microservices. They're troubleshooting, they're taking logging, they're waiting for open tracing 10 minutes until they're getting the logs. Then they forgot to print something. They need to go print it again. Really, really daunting job. So let's see what we did. OK, so this is really simple. This calculator is actually 2 microservices, right? This is the first one. As you can see, this is Visual Studio Code. And it's really simple. It's basically serving my HTML. It's reading in Go, but it's serving the HTML. And the other one, it's a Java microservices that basically getting the 2 parameter, either add or subtract, and return the result to the Go microservices. So simple, right? So now we show you what we think that should be the process. So we basically created an extension for Visual Studio Code that you can, when you actually ask for it, you can actually create some squash function. So let's do. So I want to debug I want to debug, and what I'm getting immediately is the pod list that's running in my cluster. Or only the one that I can see, of course, right, because I'm using kubectl. So I will take the first one, and then he said to me, look, in this pod, you have 1 container. Do you want to debug it? And my answer is yes. And then he said, which debugger do you feel like attaching? And this is Go, so let's go with DLV. OK. So that's running on AWS, right? And hopefully the network will play with us. We're running it right now. We're debugging it right now. Now we'll do the same thing for the other one. So we're coming here. This is IntelliJ, so it's a different IDE. The Squash debug container. Give me the list of all of them. I will take the second one because it's the Java microservices. Then I will run the only container that exists there, and then I will attach the Java debugger because it's reading in Java. OK. So I have 2 microservices running in a cluster. It's different language. And then the only thing that I actually need to do in order to debug is let's go back, click again, and I'm running it right now, debugging in live, right? So it's running on AWS. I can see I'm getting all the parameters. It's good, right? What will happen when I'll do next? So we'll jump to the other one, right? Because I put a breakpoint there. So now basically, I'm here. It's great. And let's see that's actually working. So I'm stepping into, and I see op1 equal 44 downstairs. It's great. Let's do the next one, 33. That's exactly what we wrote. And then we see that I introduce a bug. Here's the bug that I introduced, right? Basically, we see that all the parameter is good. But what I'm doing is that if it's true, I'm actually doing a minus instead of plus. But that's simple. This is actually a regular debugger. So we can actually, on live, just change the value to false, right? So it will run there. And then I will just do next. what will happen? It will jump to the other microservices soon. What happened? Wow, that's easy. That's stuck. That's interesting. Waiting. Yeah, that's embarrassing. What should I do for it? Start again? Yeah, that's very easy. Well, we kind of like stuck. We can just retry it again, and let's see what happens. Oh my gosh. The Java debugger is stuck. I love it. It's very strange. Should I stop it? Let's just stop it. Well, we will have a little bit embarrassing thing. It's never happened, ever, never. Yeah, we'll try to see if we can actually do it live, and if not, you will believe us, and we will show you a demo after it, because that's never happened. Yeah, but we can be in trouble here, right? Because it's just stuck. Yeah, well, whenever I care. I messed up here. It's probably a click one, but we will be able need to show you that again later, I guess. That's embarrassing. Okay. Never mind. You trust us? It's working. It seriously does. I think I messed it up. I think I messed it up, so I will take the responsibility here. And we will explain you how it's working right now. And then we'll tidy it up. And I'm sorry I owe you a demo once the computer will react. Wow, that's really slow. Okie dokie. So well, now we'll explain you real quick how it's working.
All right, so really quick, how is Squash working? The first thing is obviously deploying it. When we deploy Squash, it deploys the Squash server, and then also deploys Squash client that are deployed as a daemon set to your Kubernetes cluster. Now, the interaction with Squash, as we just saw, is through a VS Code extension. So the normal workflow, just like you just saw, a user would go to VS Code will talk to the Squash server, it will give it the name and namespace of the pod we wish to debug. The Squash server will find the relevant node and contact the Squash client on that node. The Squash client will talk with a component in the Kubernetes runtime called the cry and use that to find the PID that it needs to debug, and then attach a debugger to the relevant PID, returning all the information back to the IDE so the IDE can connect to the debugger. That's the
and
basic.
Then leave it alone, right? So we're basically just doing the piping, giving it back, and let you do what you need to do. So it's a regular debugger, and it's really important. Yes. So now let's talk about Envoy. Now where everybody saw that Squash is not working, let's talk about Envoy. So Service Mesh, Envoy, and Squash. So this is Service Mesh, right? We all know about it. I mean, I think that to talk about, so specifically the integration between Envoy and Squash is it have to use Service Mesh, and also I think that it's not responsible for us to talk about Envoy and not talking about Service Mesh. So this is Service Mesh. There's a few out there. The beautiful of it is that everybody's using Envoy. So here's the big vision of us, right? So let's say that I saw that there is a latency somewhere between two microservices. That's a problem. We need to fix it. And the way we want to do it is basically zoom in, right? Zoom in with two debuggers. See what's going on, what's causing this latency. And that's basically the big vision in the Service Mesh. Now, in order to do that, Envoy is the major piece that we needed to deal with it, right? That's actually the most important one. So that's what we did. We basically created a filter in order to allow us to do that. And we will talk about 1 second about the flow and a little bit about the filter with Yuval. Go for it.
All right, so we wrote an Envoy extension to help support Squash in a service mesh context. So the problem with this context is two problems. One, we don't know which pod we are going to debug, and the other is that we want to debug the relevant pod before the request hits it. And we'll just show the flow of how we use Envoy to do that. So first thing, it's a service mesh, so you have Envoy running as a sidecar configuration. The user, as before, talks with the IDE, but now it doesn't provide the IDE with a specific pod, but rather a container image that it wants to debug. And that container image can be deployed in multiple locations across the cluster. Then the user simulates a request and appends a debug header so that our filter will know to engage. The request goes through the ingress, and it doesn't matter which pod, it just hits any of them, gets to the Envoy filter that we have in Envoy. That filter sees that it has a certain header that says, oh, I need to talk with the Squash server and see if I need to debug this request. Talks with the Squash server, which coordinates again with the Squash client and with the IDE, see if this is indeed the image that the user is waiting to debug. And if that's the case, facilitates the debug session for the user. So it doesn't matter which pod it lands on. Envoy gives us the ability to see it as it travels through the cluster, and also delays the request so the debugger can attach and the user can debug the actual request before it hits the pod and not in the middle of it.
Yeah, so basically it's really simple. It's really simple. Basically the idea is that in the end of the day, the request is coming, Envoy come to Squash and say, debug me. That's really simple, right? If I'm trying to kind of up it up. Okay, so what next? Okay, we're doing this. This is pretty good. But here is the thing. My client said, as is right, that the most interesting stuff in the ecosystem right now is to see what people are building on top of the service mesh. So Envoy is commodity. This is the way that everybody will going to talk as a proxy. But there is a lot of service mesh. And we don't know yet what will happen. And a lot of people will use different ones, specifically if they're using different cloud. For instance, you're running on AWS, you most likely will want to go with AWS App Mesh because it's free. You're running on-prem, maybe S-tier, right? So you definitely will want to do that. OK, so we agree that everybody's using Envoy, and I think no one will doubt that. And then on top of it, there is some service mesh. And there are going to be more and more and more. And the thing is that eventually, I don't want to build integration with Squash for each of them. That's too expensive, very daunting idea. And also, we can actually simplify the service mesh quite a lot. This is why we built SuperGloo. It's also an open source project. The idea with that is basically to simplify. For us, it was we don't want to integrate it with every mesh. But mainly, it's an abstraction layer to make sure that it's very easy. So it's easy as tell me which mesh you want to install and install it, then flip a coin. You want observability on, off. You want retries on, off. Very, very simple one. So you have that. And then the beauty of it, we can do this. Right? We can actually plug stuff in. So this is a summon example. Ingress, right? We have glue, but there is other ingress. We're really hoping that people will integrate it. Squash. So I integrated once to SuperGlue. We work on every mesh that we support, which is most of them. And then same thing with Knative, right? There was a little bit of buzz about, is that OK that they're only using STO? They will need to abstract that, and we can help with that. And I think Tetrate is building something on top of the mesh and so on. I think that should be the way that the community is looking. And the end goal is that eventually, it's like the Mesos style, right? A lot of nodes, we will use all of this as a computer. A lot of mesh, we will use all of them as one big mesh. So I can just say policy, boom, it's applied to every mesh. I don't really care which, right? So I think we're on time, hopefully. And I'm really sorry that the demo didn't work. I only one. But we are open source. This is what Solo is doing. We're all about open source. We're all about community. Everything that we're doing is open source. Please help us, because we really think that we have good ideas here, and we would love your cooperation. And that's it, and we're hiring, of course. That's it. Thanks so much.